Hello guys, welcome once again to Albert Mathematics. Today we're looking at calculus and now we calculus part 3. So I'll entreat you, if you are new to this channel, please subscribe so that you will not miss any update from Albert Mathematics. Alright, so shall we proceed? So as I said earlier, today we'll be looking at calculus part 3 and now with differentiation from first principle. Differentiation for first principle, I've come to realize that that's one of the challenges most learners face in the topic of calculus. So shall we make a progress? So we have a sample of question here to solve, and that's f of x is equal to 4x plus 2. So you can see f of x equal to 4x plus 2 is a function. It's a function. So that's why it is being given us the principle. So we have to follow the principle and solve the functions. Alright. So from differentiation of first principle, we have the formula to be, we have it as dy over dx is equal to f prime of x, which is equal to lim of, we have f of x plus h minus f of x, and it's all over h as h approaches to 0. Right, so this is the formula we have to use. So wherever you see x, you put x plus h, and definitely the coefficient will be multiplying f plus h. So now take note, when you are using dy over dx, you don't need to bring f prime of x. When you're also using f prime of x, you don't need to bring dy over dx. Alright, so we have the sample of question here. Let's proceed and use the formula and see. So this will be equal to, when we are solving the one which is f of x is equal to 4x plus 2. So using the formula, this will be equal to, so dy over dx is equal to, remember I said if you are bringing f prime of x, you don't need to bring dy over dx. So if you are also bringing dy over dx, you don't need to bring f prime of x. Alright, so I am using dy over dx, that's why I'm not going to bring f prime of x. So dy over dx will be equal to, so I'll have lim of, I have my f of x plus h minus f of x all over h, and as h approaches to 0. So with this I'll substitute, so my dy over dx will be equal to lim of, so I have it as 4 bracket x plus h minus f of x all over h, and as h approaches to 0. But remember, f of x is the function, so we have to bring it in. So dy over dx will be equal to lim of, we have 4 bracket x plus h minus bracket 4x plus 2. Remember, the reason being that we said f of x, and f of x equal to what? 4x plus 2, or x plus 2, and all is divided by h. So with this, remember, we are supposed to bring what? We'll bring our 2 plus 2 plus 2 plus 2. So that is it. So our dy over dx will be equal to lim of, we have as, we are multiplying, this will be 4x plus 4h, we are expanding the bracket, plus 2. Then we'll use our minus to open the bracket, that will be minus 4x minus 2 all over h. We close our bracket, and remember here as h approaches to 0, So with this, you can see 4x will go away with 4x. This 4x minus 4x will tend to 0. 2x minus 2 minus 2 10 to 0, leaving only 4h. So therefore our dy over the x will be equal to lim of 4h all over h as h approaches to 0. So remember, h will cancel h, leaving only 4. So therefore dy over the x will be equal to 4. All right, so that's our answer. That's from first principle. So once again, if you are new to this channel, please subscribe so that you will not miss any update from my channel. And remember, I'll be uploading more videos on the calculus, and stay tuned to watch all the videos I am to upload. Thank you. You are appreciated.